Hey everyone, welcome to Math 7 video lesson day 8. Together we can solve two-step and multi-step inequalities and graph solutions on number lines. Example 1, two-step inequalities. Diego has budgeted $35 from his summer job earnings to buy shorts and socks for soccer. He needs 5 pairs of socks and a pair of shorts. The socks cost different amounts in different stores. The shorts he wants cost $19.95. Write, solve, and graph an inequality to represent the amount Diego can spend on a single pair of socks. Let S represent the cost of one pair of socks. So we look at this question. We notice that he budgeted $35. He needs 5 pairs. The shorts cost $19.95 and S represents one pair of socks. Writing an inequality. Consider using a flow map with words to help you write an inequality. First, Diego budgeted $35, so we know that the most he can spend is $35. He cannot spend over it, he can spend less than it, and he can spend $35. We know he bought 5 pairs of socks, or needs 5 pairs of socks. The shorts cost $19.95, and S is the cost per pair of socks. Here's our inequality. $19.95 plus 5S is less than or equal to 35. We're going to solve it using the inverse operation of subtraction and division. We subtract $19.95 from both sides of the inequality. We get 5S is less than or equal to $15.05. Divided both sides by 5. S is less than or equal to $3.01. That means Diego can spend at most $3.01 on a single pair of socks. Graphing our solution, S is less than or equal to $3.01. We have a number line, we have a closed circle at $3.01 and an arrow pointing to the left. Remember, use substitution to test possible solutions. Only numbers less than or equal to $3.01 will make the inequality true. Example 2, inequalities with negatives. Kieran has $100 saved in a bank account. The account doesn't earn interest. He asked Claire to help him figure out how much he could take out each month if he needs to have at least $25 in the account a year from now. Write, solve, and graph an inequality that represents how much money Kieran can take out of the bank account each month for 12 months. Let M represent the amount of money withdrawn from the bank each month. Again, we highlight our important information. $100 he has saved. He wants to end up with at least $25 for 12 months, and M represents the amount he takes out each month. Again, consider using a flow map with words to help you write an inequality. He has $100 saved. He wants at least $25. That's the minimum. There are 12 months that'll be withdrawing, and M represents how much is withdrawn each month. My inequality then is 100 minus 12M is greater than or equal to 25. We're going to use inverse operations of subtraction and division. Subtract 100 from both sides of the inequality. So negative 12M is greater than or equal to negative 75. Divide both sides by negative 12. M is greater than $6.25. But remember, when we divide by a negative on both sides, we reverse the symbol. So M must be less than or equal to $6.25. So at most, Kieran can withdraw $6.25 from her bank account each month. We graph this on a number line. M is less than or equal to 25, $6.25. So we put a closed circle at 620.25 and draw an arrow to the left. Remembering to use substitution to test possible solutions, only numbers less than or equal to $6.25 will make the inequality true. Let's look at example 3, solutions and context. At a local middle school, 28 students plan to travel on a field trip. They will use a van that can seat 12 students. Elena's and Kieran's teacher asks parents to drive cars that seat 3 children each to transport the rest of the students. How many parents will need to drive their cars? Write and solve an inequality that represents how many cars they will need. Let C represent the number of cars needed. We look for our important information. There are 28 students. 12 students can ride in the van, 3 students per car driven by the parents, and we're going to let C represent the number of cars needed. Remember, we can consider using a flow map with words to help you write the inequality. There are 28 students that plan to travel on the field trip, 12 seats in the van, 3 children in each car. Let C represent the number of cars needed. Our inequality is 12 plus 3C is greater than 28. We use inverse operation of subtraction and division to solve this inequality. Subtract 12 from both sides of the inequality. We end up with 3C is greater than 16. Divide both sides by 3. And C is greater than or equal to 5 1/3. But wait, does this make any sense? We have 5 1/3 cars. The students will need 6 cars. If they use 5 cars, one person will be left behind. And you can't have 1/3 of a car. That doesn't make any sense. So the final answer would be C is greater than or equal to 6. Example 4, multi-step inequalities. There are 2 ways we can solve this inequality of 4 times the quantity y minus 4 plus 8 is greater than 20. Our first way is using the distributive property, where I multiply 4 times the quantity y minus 4 and get 4y minus 16 plus 8 is greater than 20. I combine like terms, so 4y minus 8 is greater than 20. I add 8 to both sides of the inequality, end up with 4y is greater than 28. And I divide both sides by 4, so y is greater than 7. Another way to do this is multiply by the reciprocal. I chose the reciprocal of 4 as 1/4 because 1/4 can be multiplied by 8 and 20 nicely. So 1/4 of 4 and 1/4 of 8 and 1/4 of 20. I end up with y minus 4 plus 2 is greater than 5. Combine my like terms, y minus 2 is greater than 5. Add 2 to both sides, y is greater than 7. What makes sense to you? You can choose either way. We graph this inequality, y is greater than 7. I have an open circle at 7 with an arrow pointing to the right. Remember, use substitution to test possible solutions. Only numbers greater than 7 will make the inequality true. Together, we solve 2-step and multi-step inequalities and graph them on a number line. It's your turn to practice. Use the practice problems and keys for Math 7 Video Lesson Day 8, provided at www.aacps.org. Click on AACPS e-Learning. For additional practice problems, please visit your textbook or online through ClassLink Pearson. Topic 5, Lessons 6 through 7.